The divide and conquer strategy. In the divide and conquer strategy, we have three steps. The first step is divide. So we divide the problem into subproblems. Here, the subproblems are very similar to the original problem, but the number of instances will be less. Second step is conquer step, where we solve the subproblem either recursively or non-recursively, which is conquering the solutions. Next, we combine. So the solution of the subproblems can be combined to get the global result of the original problem. So first we divide, we conquer the sub-solutions, then we go for combining the sub-solutions into the global result. So divide and conquer strategy is when we have a problem, we first try and divide it into sub-problems. Then we try to find the sub-solutions of those sub-problems. When we are done with finding the sub-solutions, we try to merge the sub-solutions into solution. So it is basically divide, conquer, and merge the solution. So whenever we are given with a problem, we can solve it in n number of ways. We have so many strategies to solve the problem. So this is one such strategy, which is called divide and conquer strategy. So this is the algorithm for the divide and conquer strategy, general algorithm. So whenever we have an algorithm, it has an input and it has an output. So this algorithm takes problem P of size n as the input. So you may imagine sorting n numbers or searching a number in n numbers. So where the size is n. So what is going to be the output? The output is the solution of the problem. So first, what we are going to do is, first step is identify what is the size of the problem and assign it as n. If this n is less than or equal to the threshold, then I will be solving the problem using a conventional method. Say for example, if it is a factorial of n numbers. So always there is a small value where I should know the answer. So factorial of 1 is 1. So that is the most smallest value for which is below my or equal to my threshold. Now if the value is greater than the threshold, then I go for dividing the problem into smaller subproblems. So here it is, I'm dividing the problem into k number of subproblems. P1 is one part, P2 is another part. Similarly, into k number of parts, I'm splitting the problem. It's not always the same. I'm not going to divide the problem into two halves always. It can be different. So each sub-problem can be of varying sizes. So here it is S1, S2 till Sk. Now, as I divide the problem, I will have to find the solution. For every sub-problem, I'm going to repeatedly use the divide and conquer strategy, and then I'm going to find the sub-solution of all these sub-problems. Once that is done, I'm going to combine all the sub-solutions and make it as my solution. So this is the algorithm for divide and conquer strategy for a problem P of size n. So whenever we are going to solve a problem using divide and conquer strategy, we can represent the solution in the form of a recurrence equation. So here we had a problem P, right? Its size is n. So how am I going to represent it? So T of n is equal to A T of n by B plus f of n. So here A is the number of sub-problems. If I have a problem and I'm going to divide it into two parts, then this is going to be 2T of n by B. N is the actual size of the problem. So if I have 20 numbers to be sorted, this n is going to be 20. N by B is the size of the sub-problem, and f of n is the cost of work done for all the non-recursive calls. There are so many ways of solving the recurrence equation. The most popular methods are substitution method, which can either use a forward substitution or a backward substitution. The second one is the recurrence tree method, and finally the third one is the Master's theorem. So using divide and conquer strategy, we can solve many problems. The most commonly taken examples are binary search, merge sort, quick sort, Strassen's matrix multiplication, finding the maximum and minimum element in an array, maximum sub-array sum, closest pair of points, and convex hull.